Good morning, students. Myself, Vijay Shankar from ECE department, Chipro Engineering College. Today, we are going to discuss about the wave equations in phasor form and uniform plane wave in perfect dielectric. Nothing but it's a lossless dielectric and a lossy dielectric, and the uniform plane wave in good conductor and the practical dielectrics. So the different uniform plane waves for the perfect dielectric, perfect conductor, practical dielectric, and the lossy dielectrics. So before that, we can discuss about the waveform equations in the phasor form. So already we derived the equations, the waveform equations. Now you can see that the waveform in the phasor form. Okay. The wave equations in phasor form. An electromagnetic wave in a medium can be completely defined if intrinsic impedance beta and propagation constant gamma of a medium is known. So we know that eta is equal to the ratio between already discussed in the previous class. Eta is equal to the ratio between of EM plus by the HM plus or minus EM minus by HM minus, and the propagation constant gamma is equal to alpha plus I beta, where alpha is attenuation constant and beta is a phase constant. The same propagation constant we use in the transmission line, that is represented as a P. Here in the waveform equations or the wave equations, the gamma is represented as a propagation constant. Okay, my dear students, so don't confuse here. Thus, it is necessary to derive the expressions for eta, gamma in terms of the properties of the medium, mu, epsilon, and the conductivity. Already we know the intrinsic impedance eta is equal to the ratio between of EM plus by the HM plus is equal to minus EM minus the coefficients of the equation, HM minus, that is equal to under root of mu by epsilon. We got this equation, mu by epsilon, or the mu naught by the epsilon naught, because we derive the wave equations in the free space. Epsilon r is equal to 1 and the mu r is also is equal to 1. The 377 ohm intrinsic impedance in terms of the ohms only 120 pi, or it is also equal to the 377 ohms. Okay. So now you can derive the eta and the gamma in terms of its properties of a medium, such as permeability mu, permittivity epsilon, and the conductivity sigma, etc. The gamma is equal to alpha plus I beta. Okay. To derive these two expressions in terms of the constant values, consider a Maxwell's equation derived from the Faraday's law. The del cross E bar is equal to minus dou B bar by 2. Derived from the Faraday's law, this is one of the Maxwell's equation. Del cross E bar is equal to minus dou B bar by dou T. B bar is equal to the relation between of B and the H is a mu into H bar. So minus mu into dou H bar by dou T. Taking the curl on both sides, taking the curl function on both sides, del cross E bar is equal to minus mu into del cross dou H bar by dou T. The mu is the constant. So applying the del cross H bar, then it becomes of del cross E bar is equal to mu minus mu into del cross dou H bar by dou T. We can written as a dou by dou T of del cross H bar. Okay, my dear students. In the left hand side, del cross E bar is equal to, upon the one of the property of curl function, del dot del dot E bar minus del square E bar is equal to, okay, del cross E bar is nothing but del dot E bar minus del square E bar is equal to minus mu into dou by dou T of del cross H bar. Okay, the one of the Maxwell's equation derived from the Ampere circuit law, del cross H bar is equal to sigma into E bar. So before that, you have to know that is a JC bar plus JD bar. That is nothing but the J one. J bar is equal to del cross H bar is equal to J bar, Ampere circuit law saying, and modified Ampere circuit law del cross H bar is equal to conduction current density plus displacement current density JD bar. JC is equal to sigma into E bar, and JD bar is a dou by dou T of T bar. If it is in terms of the E bar only, sigma into E bar plus the relation we know, T bar is equal to epsilon into E bar. The relation between of the electric flux and the electric field. So dou by dou T of D bar you can replace as epsilon into E bar is equal to sigma into E bar plus epsilon is a constant, you write the outside, epsilon into dou by dou T of E bar. Okay. This is for the del cross H bar from the modified Ampere circuit like the Maxwell's equation. Substitute the del cross E bar as this equation, the sigma into E bar plus epsilon into dou by dou T of E bar. Okay. Now in the left hand side, del dot E bar is equal to 0. Del dot E bar is equal to 0. It becomes of 0 minus del square E bar. Del square E bar is equal to minus mu into is a dou by dou T. See, the dou by dou T, I told that replace in the one of the Maxwell's equation, the harmonically time varying fields, dou by dou T is equal to J omega. Dou by dou T is equal to J omega. How we got this D bar is equal to D naught into E power J omega. Okay, E power J omega T, let us take that. Or E bar is equal to D E naught into E power J omega T. Now you can apply the dou with respect to the dou by dou T of dou D bar by dou T with respect to the time we are applying here, D naught into E power J omega T into J omega. Okay, my dear students. So apply the both sides with the dou by dou T. The dou by dou T of E power J omega T is a E power J omega T into J omega. So dou by dou T of D bar is equal to D naught into J omega E power J omega T. So before that you can write this D naught into E power J omega T into J omega. Got it, madam? What is a D bar? D naught into E power J omega T, nothing but the D bar. So dou by dou T of D bar is equal to, this function is already the D bar into J omega. So see the left hand side and the right hand side, the D bar is there. And what is the dou by dou T? Nothing but J omega. So wherever the dou by dou T is there, you can replace with the J omega. So we already applied in that the fourth table of the Maxwell's equations dou by dou t is equal to j omega harmonically time varying fields. Okay. So now wherever the dou by dou t is there, replace that as a j omega here into sigma into E bar plus epsilon into, here also dou by dou t is there, replace that is a j omega into E bar. Got it, my students? So in the left hand side we have minus del square E bar minus del square E bar is equal to, here the function is there, multiply with minus, so here the minus and here also the minus is there, get it is a plus, both sides there is a minus, multiply with the mu into j omega inside, the mu j omega into sigma E bar plus, and here the mu j omega j square is there, okay, j square mu into j omega whole square epsilon is also there, epsilon into mu j omega whole square into E bar. Got it, my students? Okay, these are, after the simplifying we got this equation. Del square E bar is equal to mu into j omega sigma into E bar plus epsilon into mu j omega whole square into E bar. Here also the E bar is there. Got it, my students? Then you see here the equation. Finally, we got del square E bar is equal to, I will erase this one. Del square E bar is equal to mu into j omega. So here the j bar plus jd bar is equal to, I replace as j omega sigma into E bar plus j omega epsilon into E bar. Got it, my students? See the j omega mu into sigma E bar plus j omega mu into epsilon. Here the square is there, my students. Here the square. Okay. Del square E bar is equal to j omega. You can multiply here. J omega mu into sigma E bar plus, here the j omega and here also the j omega. J omega whole square. The printing mistake here. Epsilon into mu E bar. In these two functions, whatever we got derived up to this equation, in this function we can take the common of j omega mu. In the two terms we have, the common term is a del square E bar is equal to, del square E bar is equal to, take the j omega mu as a common. So sigma plus j omega epsilon into E bar. Got it, my students? Is the equation 6. Del square E bar is equal to j omega mu is a common term is sigma into E bar is there, and here also the one j omega you get the common and mu remaining is j omega epsilon into E bar. Okay, my students. And this function we can call it as a del square E bar is equal to gamma square into E bar. Del square E bar is equal to this total function we can write as a gamma square into E bar. Now what is a gamma here? The phase propagation constant. Gamma square is equal to j omega mu into sigma plus j omega epsilon, and gamma is equal to under root of j omega mu sigma plus j omega epsilon, the propagation constant. Okay, my students. So you see from that equation the del square h bar is equal to the same thing. Here the E bar is there. Del square E bar is equal to j omega mu into sigma plus j omega epsilon into E bar. In similar way, we can also written as the phase equation in terms of the h bar. Both are the same. Del square h bar is equal to j omega mu into sigma plus j omega epsilon h bar. The term inside the bracket in the equation 6 and the 7. 6 is in the electric field. Okay. That is a del square E bar is equal to, we got del square E bar is equal to the same function multiplication. J omega mu into sigma plus J omega epsilon whole multiplied with E bar. Okay. Similarly, we can write the another phase equation in terms of H bar. The term inside the bracket in equation 6 and the equation 7, this equation 6, are exactly similar and represent the properties of medium in which the wave is propagating. The wave is propagating. The total term is the square of the propagation constant gamma. Square of the propagation gamma square. Gamma square is equal to the whatever there is in the parenthesis. Gamma square is equal to, within the parenthesis for the two equations, the 6 and the 7. Okay. The total bracket in the square of the propagation constant gamma is equal to J omega mu into sigma plus J omega epsilon. And gamma is equal to, see, the gamma is equal to under root of J omega mu into sigma plus J omega epsilon. What is the gamma here? The propagation constant gamma is expressed in terms of the properties of the medium. See, what is the properties of the medium? Mu is the permeability and epsilon is the permittivity and the omega is the frequency. Got it, madam? The real and imaginary parts of the propagation constant gamma are attenuation constant alpha and the phase constant beta. Got it, madam? Remember, it is a very, very important equation, the phasor wave equation for the phasor form. That is gamma is equal to under root of J omega mu sigma plus J omega epsilon. Got it, madam? Under root of J omega mu sigma plus J omega epsilon. So in this, the alpha is equal to this equation, the beta is equal to this equation. So alpha is nothing but an attenuation constant. When we can say it is a lossy dielectric and the lossless dielectric means lossless dielectric means alpha is equal to 0. We already know in the transmission line equation, when attenuation constant is a 0, then we can call it as a distortionless transmission. Here, lossless dielectric, the waveform equation, uniform plane wave in lossless dielectric means alpha is equal to 0. When it is alpha is equal to 0 means we know the JC bar by the JD bar. The magnitude of JC bar by the JD bar is equal to sigma by the omega epsilon. There is a two conditions we have. Less than 1 is a perfect dielectric. And sigma by the omega epsilon is very much greater than 1, is a perfect conductor. Okay, my dear students. So when it is alpha is equal to 0, nothing but this attenuation is a 0. If there is no attenuation, there is no any loss in the transmission. In the propagation constant gamma is equal to where the alpha is equal to 0. So sigma by the omega epsilon. When it is a lossless, sigma by the omega epsilon, the value is very much less than the 1. It's say take this condition. Very much less than the 1. It's a perfect dielectric. Okay, less than the 1 means see here the alpha is equal to. Listen carefully, my dear students. The alpha is equal to the equation we got here from gamma is equal to alpha plus I beta. Alpha is a real part and the beta is an imaginary coefficient. So in this alpha, when it is a lossless and when it is a lossy. Lossless means lossless is alpha is equal to 0. I mean that it is a sigma by the omega epsilon is very much less than the 1. So here the 1 is there. When compared to the 1, the sigma by the omega epsilon is very, very less. So in this under root of 1 plus sigma by the omega epsilon is very much less than the 1, means the square is also the very much less than. So it is a 0. Neglecting the term, simply saying that, not the 0, neglecting the term. So under root of 1 is 1 only. And here the 1 minus 1. 1 minus 1. In this under root, sigma by the omega epsilon is very much less than, means compared to this 1, we are neglecting this term. Under root of 1 is 1, and 1 minus 1 is equal to 0. Alpha is equal to 0. So it is a lossless dielectric. Okay. Perfect dielectric means it is a lossless dielectric. Got it, my students? And now, what is a beta now? We already know the beta is equal to omega root LC in the transmission line. Alpha is equal to 0. It's a lossless transmission line or distortionless transmission line. What is a beta? Beta is equal to, we got the omega under root of LC. There is a constant is L and the C, where L is the inductance and the C is a capacitance, my dear students. This is for the transmission lines and the distortionless transmission. Now in this propagation constant, the wave propagation, what is a beta value? Similarly, here also observe 1 plus gamma by the omega epsilon. The value of the 1 is very much less than the 1, means we are neglecting the term. Under root of 1 is 1. 1 plus 1 is there here. 1 plus 1, nothing but the 2. So beta is equal to, we got omega under root of mu epsilon by 2, and again is whole multiplied with under root of 1 plus this term is neglecting. Under root of 1 is 1 and plus 1. Previously is under root of 1 is 1 and the 1 minus 1 we got as a 1 minus 1 is a 0. So the alpha I got the 0. Now what is a beta? 1 plus 1 is a 2. 2 by 2 is get cancelled. So beta is equal to omega under root of mu epsilon. So in the transmission line, distortionless transmission means omega, the frequency under root of the parameters we have, the constant parameters L and the C. What is the constants here? Permeability and permittivity, mu and the epsilon. Omega is omega under root of mu epsilon. What it matters to us? Okay. When it is a lossless transmission, not the transmission here, lossless dielectric. Here the distortionless transmission. Attenuation is a 0. There is no any loss. There is no any distortion occurs in the transmission. And here also, when alpha is equal to 0, attenuation is a 0. There is no any attenuation for occurs. So the propagation constant gamma is equal to, only we have the beta. That beta value is omega under root of mu epsilon. So gamma is equal to 0 plus j into omega under root of mu epsilon is the propagation constant for lossless perfect dielectric. Okay, so how we got the alpha and the beta? That is a very important. How we got that equation omega under root of mu epsilon by 2 and whole multiplied with under root of 1 plus sigma by the omega epsilon whole square minus 1. We already derived that alpha and beta in the transmission line also, my dear friends. But in the transmission line, we don't have any epsilon and the mu and the sigma. There is no any conductivity, dielectric and okay, my dear friends, how we got the alpha and the beta actually? How we got this equation? We already find that what is a lossless means alpha is equal to 0. and beta is equal to omega under root of mu epsilon. That gamma is equal to 0 plus omega under root of mu epsilon. Okay, this is for the lossless dielectric. Lossless dielectric is a uniform plane wave. The propagation constant having the alpha is equal to 0, nothing but attenuation constant, and the phase constant beta is equal to, in terms of the parameters of mu and epsilon. And how we got the alpha and beta? The real term and the imaginary term, the derivation part. We already seen the alpha is equal to beta is equal to the transmission line. That is a different. Okay, that is in terms of the L at the parameters what we have, the R, L, and the G and the C. But here there is no any R, L, G, and the C. That is a different propagation constant, alpha attenuation constant, and the beta phase constant. But now here the alpha is in terms of the one of the parameters, the dielectric constant and permittivity. So taking that square on both sides to get the alpha and the beta, alpha plus I beta is equal to alpha plus I beta is whole square is equal to j omega mu sigma plus j omega epsilon. Okay, so alpha is alpha square, I square is a minus beta square plus 2I alpha into beta is equal to j omega mu into sigma plus, and here the multiplication j omega square into mu epsilon. So what is the real term in the left hand side? Alpha square minus beta square. Alpha square minus beta square is equal to, and here j square is a minus. Okay, here the j omega mu into sigma is for the alpha beta. 2 into alpha beta is equal. The imaginary coefficient is a 2 alpha beta is equal to, we got as omega mu sigma. The coefficient of muimaginary is omega mu sigma, and here the j square is a minus omega square mu epsilon. Got it, Madhu? The real term is alpha square minus beta square is equal to omega square mu epsilon, and alpha and beta is equal to omega mu sigma. From this we can derive the alpha and the beta values. Okay, Madhu? From these functions, alpha square minus beta square is convert the beta as, what is the beta here? The 2 alpha beta is equal to, means 2 alpha and the beta is equal to omega mu sigma is there, and beta is equal to omega mu sigma by the 2 alpha. Substitute the beta here, alpha square minus beta square. What is the beta square? Omega square mu square sigma square by 2 alpha, nothing but that 4 alpha square is equal to minus omega square mu epsilon. Now we have this equation having only the alpha square on. Got it, my dear friends? So alpha square, simplify this equation to get the alpha. To get the beta, alpha is equal to omega mu sigma by 2 beta. Substitute here the alpha is equal to, alpha in terms of alpha is omega square mu square sigma square by 4 beta square minus beta square is equal to minus omega square mu epsilon. So simplify this equation to get the beta. Okay, my dear students. Like that we got the alpha and the beta function. Okay, taking that the squaring on both sides and the imaginary coefficient you can compare and the real coefficient comparing. Substitute the alpha and the beta in alpha square minus beta square. We'll get alpha is equal to this equation, the beta is equal to this equation. And this comparison, sigma by the omega epsilon, when less than the 1 is a perfect dielectric, greater than the 1 is a good conductor or perfect conductor. Got it, my students? So now the intrinsic impedance. We got the alpha and the beta, nothing but the combination of attenuation and the phase is the phase propagation constant gamma. The intrinsic impedance of a medium can be expressed in terms of the properties of a medium and is given by, what is the eta here? Eta is equal to the coefficient what we have here, the alpha gamma is equal to j omega by this one. So j omega mu by sigma plus j omega epsilon. Whether it is a right or wrong, we can see the eta is equal to, we know eta is equal to under root of mu by epsilon. Okay, mu by epsilon. See, when it is a perfect dielectric. In comparison, the sigma plus j omega epsilon, sigma by the omega epsilon is very much less than the 1, where sigma is very much less than the omega epsilon. In comparing the denominator here, sigma term is comparing the omega epsilon is very, very less value. So neglecting this term, eta is equal to j omega mu is under root minus by, we are neglecting this term, we have only the denominator is j omega epsilon. J omega get cancelled, and then the eta is equal to under root of mu by epsilon. So we got this one. Okay. So the intrinsic impedance of a medium can be expressed in terms of the properties of the medium is given by eta is equal to j omega mu, and the denominator is sigma plus j omega epsilon. Got it, my students? And it is a perfect dielectric. The sigma by the omega epsilon, the sigma by omega epsilon is very, very much less than the 1. Neglecting this term, under root is a 1, and the eta is equal to under root of mu by epsilon. Got it, my students? So now, the next one is uniform plane wave in the perfect dielectric. Uniform plane wave in the perfect dielectric. I also told that in a medium through which the uniform plane wave is propagating in a perfect dielectric, it is a lossless dielectric, which is also called as a lossless dielectric. Got it, my friends? Then the conductivity is a 0. Means the sigma by the omega epsilon is very much less than the 1. Means dielectric is high compared to the conductivity. Conductivity is a 0 here. So sigma is equal to 0. Substitute the sigma is a 0 here. The gamma is equal to plus or minus j omega under root of mu epsilon. What is alpha here? It is only the coefficient of imaginary. Alpha is equal to 0. Gamma is equal to alpha plus j beta plus or minus j omega under root of omega mu epsilon. In the equation 1, it is clear that propagation constant is purely imaginary. It indicates in a perfect dielectric medium, attenuation constant is a 0, and the value of beta which propagates the wave in a positive z direction, alpha is equal to 0, beta is equal to omega mu epsilon. Similarly, the intrinsic impedance in the perfect dielectric medium, eta is equal to sigma is a 0 means under root of mu by epsilon is a perfect dielectric. Okay. And then thus the intrinsic impedance eta is a real resistive. That means the phase angle of intrinsic impedance is a 0. But the phase angle of intrinsic impedance is 0 means phase difference between E bar and H bar is also 0. In other words, a perfect dielectric, both the fields E bar and H bar are in phase, the same angle. How we will get this one? There's intrinsic impedance eta is a real resistor. That means the phase angle of intrinsic impedance is a 0. Phase angle of intrinsic impedance is 0, but the phase angle of intrinsic impedance is 0 means the phase difference between there is no any angle here. Phase difference between these, the E bar and H bar is a 0. In other words, perfect dielectric, both the fields are in phase. Means nothing but the 0. Okay. As a perfect dielectric, sigma is a 0, Attenuation alpha is also 0. Sigma means conductivity is a 0. If conductivity is a 0, alpha is also the 0. As the wave propagates, only the phase changes. Thus, no attenuation means no loss. No attenuation means alpha is equal to 0, means no losses. So the perfect dielectric medium is also called as a lossless dielectric. Lossless dielectric. Okay. And in this, the velocity of the propagation in the perfect dielectric is given by, we know already the velocity is in terms of 1 by under root of epsilon, that is omega beta, and also the velocity is a lambda into f. We already derived these equations in the wave equations. Okay, in the free space. The velocity of propagation in the perfect dielectric is given by v is equal to 1 by root of mu epsilon and the omega by beta, or in terms of the wavelength, lambda into f. Okay, my